Welcome to my class. I'm Drew Collop. In today's class, we're going to continue talking about conversions. In our last class, we spoke about measurements, specifically the SI units of measurement, and we talked about converting units using conversion factors. Today, we're going to expand on that to talk about converting rates and converting exponential values. Let's begin with rates. Rates consist of two or more units. We have speed, kilometers per hour, density, grams per liter, and flow, milliliters per minute. Converting rates just requires one additional step. Let's go through the process and an example at the same time. Step number 1, write down what's given. So I want to go from 4.5 milligrams per centiliter to grams per liter. So write down what's given. 4.5 milligrams. When I write this down, I'm going to write the centiliters on the bottom because this is a fraction. I am then going to determine what my conversion factors are with the correct numerator and the correct denominator. I will then write out the equation. So here I'm going to multiply. I want to go from milligrams to grams. So I want to go from milligrams to grams. Notice I have milligrams on the top, so I put milligrams on the bottom, so they will cancel each other out. One bonus of using conversion factor method is that we can do multiple conversion factors in the same equation. So what we can do here is I can multiply by another conversion factor. This conversion factor will be converting from centiliters to liters. Now the question is, where does centiliters go? Centiliters will go on the top and liters on the bottom. Why is that? Because I have centiliters on the bottom, so in order for that to cancel out, I have to have centiliters on the top. So you can see my conversion factor has to be the inverse of what we've been working with before. Let's write our units in. Grams is bigger than milligrams. There's going to be a whole lot of milligrams in 1 gram. Milli means 10 to the minus 3, so there's going to be 1,000 milligrams in 1 gram. Let's look at centiliters and liters. Liters is bigger. There's going to be a whole lot of centiliters in 1 liter. Centi is 10 to the minus 2. Therefore, there will be 100 centiliters in 1 liter. We will then multiply the top values and the bottom values. Units will cancel out, leaving you with the proper units in the end. So milligrams cancels milligrams. Centiliters cancels centiliters. Notice I have grams over liters, which is exactly what I asked for here. Work that all out now. 4.5 times 10 to the 3 goes from the bottom to the top when I switch the exponent to a negative symbol, and 10 to the 2 is already on the top. And again, my units are going to be grams divided by liters. Combine these together. 4.5 times 10, negative 3 plus 2 is going to be negative 1 grams per liter. Final answer. As you can see, one bonus of conversion factor method is I can do the conversion in one long equation. This will be very important later on in stoichiometry. You'll understand then. Let's work through example 2. So as always, we're going to write down what we're given. We're given 12.9 milligrams per kilometer. I'm just going to put a 1 there to signify that would be the unit there. We have milligrams per kilometer, and I want to go from milligrams to nanograms, and I want to go from kilometers to centimeters. So I'm going to draw a little game plan here. So let's first convert from milligrams to nanograms. Let's go from milligrams to the standard unit grams, and then we'll go from our grams to our nanograms. Next up, let's convert from kilometers to centimeters. Kilometers is on the bottom, so kilometers is on the top here. Standard unit on the bottom there, meters. And then here we're going from meters to centimeters. Notice here, I haven't written any numbers down, but I have a game plan in place. In green, I'm going from milligrams to nanograms. And in blue, I'm going from kilometers to centimeters. Now let's put in the units associated with those values. Grams is bigger. 1 gram is 1,000 milligrams. Nano means 9, right? 10 to the 9 nanograms in 1 gram. Kilometers, kilometers is bigger. There's 1,000 meters in a kilometer. And centi means 100. 1 meter is 10 to the 2 centimeters. Let's now cancel out our units. Milligrams cancels milligrams. Grams cancels grams. Kilometers here cancels this kilometers over here. Meters cancels meters. I'm left with nanograms divided by centimeters. Exactly what I asked for. Now let's do all the math. 12.9, 10 to the 3 comes up to the top, becomes 10 to the minus 3, times 10 to the 9, times 10 to the minus 3, times 10 to the minus 2. And our units, again, are nanograms per centimeter. We will now combine all of these together. Do you see how important it is that you fully understand your exponent laws? 12.9 times, I'm doing -3 plus 9 minus 3 minus 2 nanograms per centimeter. Now, you don't have to show that step. I'm just doing this extra step to make sure I don't lose you. This is then equal to 12.9 times 10. -3 plus 9 is positive 6. Minus 3 is positive 3. Minus 2 is positive 1. Nanograms per centimeter. Is this the final answer? It is not. It's not in proper scientific notation. I take a 12, make it into 1.29. I made this number smaller. Here I divided by 10. To make sure this is balanced, I have to multiply this by 10, giving this 10 to the 2 nanograms per centimeter. Final answer. As you can see with rate calculations, we're going to have units in the numerator and the denominator. As a result, when we make our conversion factors, it is important we place the unit to be canceled out in the correct spot in the fraction. Let that be the numerator or the denominator. We have some practice problems here. Notice this is 2. This is a continuation from our practice problems from last lecture. So we have 2a, b, and c. Give these a try now. Because I think they're so important, I will take all of them up. But make sure you try them first, so you have a true assessment of whether or not you understood these concepts. Try that now. Let's take these up now. We're given 7.32 grams per liter. What's my game plan? I'm going from grams to milligrams, and I'm going from liters to centiliters. Let's do that now. Going from grams to milligrams. Grams is on the top, so grams needs to be on the bottom here. Milligrams up there. Grams is bigger. In 1 gram, there'll be a whole lot of milligrams. Milli is 10 to the minus 3, so there is 10 to the positive 3 milligrams in 1 gram. That one's done. Next up, we want to go from liters to centiliters. Conversion factor. Now notice, liters is on the bottom, so I have to put liters on the top so they cancel each other out. Centiliters goes on the bottom. Liters is bigger. There's going to be a whole lot of centiliters in 1 liter. Centi is 10 to the negative 2, so there's going to be 100, 10 to the 2 centiliters in 1 liter. Cancel out your terms. Grams cancel out. Liters cancel out. Leave me with 7.32 times 10 to the 3 times 10 to the minus 2 units, milligrams per centiliter. Exactly what I asked for. Combine those together. 7.32 times 10, 3 minus 2 is 1, milligrams per centiliter. Please remember when you're doing conversion factors to put the actual unit in the final answer. The whole purpose of this is we're converting from one unit to another. It's very important you include your units in all the numbers moving forward. If you forget to put the final units in, this whole exercise is a waste of time. Don't forget that. Let's do B now. Write down what we're given. 34.3 kilometers per nanogram. So I want to go from kilometers to millimeters. Then we'll go from nanograms to kilograms. Let's do that now. First of all, I want to get rid of kilometers. So I place that on the bottom. Go to the standard unit meters there. Go from meters to millimeters. Next up, I want to get rid of nanograms. Nanograms is on the bottom, so they cancel out. I have to put that on the top. Go to the standard unit grams, and then go from grams to our kilograms. Let's put in our values now. 1 kilometer, 10 to the 3 meters. 1 meter, 10 to the 3 millimeters. Alternatively, you could have said that 1 kilometer is 10 to the 6 millimeters. Over here, 1 gram, 10 to the 9 nanograms. 1 kilogram, 10 to the 3 grams. Alternatively, you could have said that 1 kilogram is 10 to the 12 nanograms. Cancel out units now. Kilometers, kilometers. Meters, meters. Nanograms, nanograms. Grams, grams. Left with millimeters divided by kilograms. Millimeters divided by kilograms. Do the math now. 34.3 times 10 to the 3 times 10 to the 3 times 10 to the 9 times 10 to the 3 millimeters divided by kilograms. 34.3, combine all of your base 10s together, times 10. 3 plus 3 is 6, plus 9 is 15, plus 3 is 18 millimeters per kilogram. This is not proper scientific notation. Convert that from 34.3 to 3.43. I had to divide by 10, so I multiply this side by 10. Millimeters per kilogram. Done. Don't forget to put your answer in proper scientific notation at the end. See now. 567.4 milliliters per kilogram. We're going to go from milliliters to microliters, and then we're going to go from kilograms to centigrams. Let's work that out. Milliliters to liters, and then liters to microliters. Kilograms is on the bottom, so kilograms has to go on the top here. Kilograms to grams, and then grams to centigrams. Put our values in here. 1 liter, 10 to the 3 mils. 1 liter, 10 to the 6 microliters. 1 kilogram, 10 to the 3 grams. And 1 gram is 10 to the 2 centigrams. Milliliters cancels milliliters. Liters cancels liters. Kilograms cancels kilograms. Grams cancels grams. Microliters divided by centigrams, exactly what was asked for. Giving me 5674. This comes up to the top. 10 to the minus 3 times 10 to the 6 comes up to the top, times 10 to the minus 3 comes up to the top, times 10 to the minus 2. Units, microliters per centigram. Combine all your base 10s. Negative 3 plus 6 is positive 3. Minus 3 is 0. Minus 2, negative 2. Microliters per centigram. Not in proper scientific notation now. Have to move this over 2 decimal places, meaning I had to divide by 100. So I have to multiply by 100 here, which is the same as adding 2, 10 to the 0. Microliters per centigram, which I could write this as 5.674 microliters per centigram. Remember, 10 to the 0 is just 1. As you can see with rate conversions, you have units in the numerator and in the denominator. Be careful when you create your conversion factors that you put it in the right location, whether it be numerator or denominator, so that they properly cancel out. In this lecture, we're also going to talk about exponential conversions. How do we convert values that have an exponential unit to it? Let's look at that now. So when units are raised to a power, the conversion factor, only the conversion factor, must also be raised to that power. Let me show you what I mean. Write down what I'm given. 12 kilometers cubed. I want to go from kilometers cubed to meters cubed. Let's figure out our conversion factor. Now, if I'm talking about kilometers and how it relates to meters, 1 kilometer is 10 to the 3 meters. But I don't care about kilometers and meters. I care about kilometers cubed and meters cubed. Now remember, in an equation, I can do whatever I want as long as I do the same thing to both sides. So what I'm going to do is I'm going to cube both sides. Here and here, here and here. This will then give me 1 cubed is 1 kilometer cubed. That's equal to 10 cubed meters cubed. Finally, 1 kilometer cubed is 3 times 3 is 9, 10 to the 9 meters cubed. So this here is the conversion factor you're required to use when you're dealing with exponential units. Let's write that down. Alternatively, you could just do this. Kilometers on the bottom, meters on the top. 1 kilometer is 10 to the 3 meters. But I'm going to cube both the top and the bottom. This will then give me 12 kilometers cubed multiplied by 10 to the 9 meters cubed divided by 1 kilometer cubed. Now I have the same units here and here. They cancel each other out. This will leave me with 12 times 10 to the 9 meters cubed. Not in proper scientific notation, 1.2 times 10 to the 10 meters cubed. Final answer. So when dealing with exponential units, you must also apply that power to your conversion factor. Let's now try 8 together. 1 centimeter cubed per liter. So notice this is not only an exponential conversion, but also a rate conversion. So I'm going to go from centimeters cubed to meters cubed, and then I'm going to go from liters to centiliters. Let's work that out now. Centimeters on the bottom, meters on the top. 1 meter is 100 centimeters. But I'm not dealing with centimeters, I'm dealing with cubic units. So I'm going to cube the top and the bottom. Next up, I want to convert liters to centiliters. Liters is on the bottom, so I must put it on the top of the conversion factor. Centiliter goes on the bottom. 1 liter is 10 to the 2 centiliters. This gives me 1 centimeter cubed divided by liters multiplied by 1 meter cubed over 2 times 3 is 6 centimeters cubed multiplied by 1 liter over 10 to the 2 centiliters. Cancel out your units now. Centimeters cubed, liters, liters. I'm left with meters cubed per centiliter. Meters cubed per centiliter. This will give me 1 times 10 to the minus 6 times 10 to the minus 2 meters cubed per centiliter. Combine those together. -6 plus -2 is -8 meters cubed per centiliter. Final answer. So in this problem, we had both a rate conversion and an exponential conversion. For a rate conversion, make sure you put your units to cancel out in the right location, whether it be the numerator or the denominator of the conversion factor. For exponential conversions, make sure you apply the power to the entire fraction, that is the conversion factor. We have a number of practice problems here. This is a continuation of the practice you've been doing during this lecture and our last lecture. So here we have 3a and 3b. Give these a try now, and again, I will take them both up. Let's take up A. Write down what we're given. We're given 12 kilometers cubed. I want to convert that from kilometers cubed to nanometers cubed. I'm going to go from kilometers to meters, and I'm going to go from meters to nanometers. 1 kilometer is 10 to the 3 meters, and 1 meter is, remember, n, nano, n for 9, 10 to the 9 nanometers. Now, because this is cubed, I have to cube all of these values here. This will give me 12 kilometers cubed multiplied by 3 times 3 is 9, meters cubed over 1 cubed, which is just 1, kilometer cubed over here, 10 to the exponent 9, raise the exponent 3, 9 times 3 is 27 nanometers cubed over 1 meter cubed. Ask yourself, does that make sense? 1 meter cubed is a pretty big value. Nanometers cubed is a very small value. So you can see that does make sense. Let's get rid of our units. Kilometers cubed cancels kilometers cubed. Meters cubed cancels meters cubed. And I'm left with nanometers cubed. Exactly what I was asked for. 12 times 10 to the 9 times 10 to the 27 nanometers cubed. Combine our bases of 10 together. 12 times 10, 9 plus 27 is 36 nanometers cubed. This is not in proper scientific notation. 1.2 times 10 to the 37 nanometers cubed. Now ask yourself, does that make sense? 12 kilometers cubed is a very large volume. Compare that to nanometers cubed. There's going to be a whole lot of nanometers cubed in 12 kilometers cubed. Therefore, it makes sense that this unit here is positive 37. Let's do our last one here. Exponential and a rate calculation. 4 kiloliters per millimeter cubed. So I'm going from kiloliters to milliliters, and then I'm going from millimeters cubed to kilometers cubed. Kiloliters goes on the bottom, liters on the top, liters, milliliters. 1 kiloliter is 10 to the 3 liters, and 1 liter is 10 to the 3 milliliters. Alternatively, you could have said that 1 kiloliter is 10 to the 6 milliliters. In terms of our conversions over here, I want to go from millimeters on the bottom, so I have to put millimeters on the top to the standard unit in meters. And over here, meters, kilometers. Write these in. 1 meter, 10 to the 3 millimeters. 1 kilometer, 10 to the 3 meters. Alternatively, you could have said 10 to the 6 millimeters is 1 kilometer. Now remember why this works out. 1 meter is 10 to the 3 millimeters. But I'm going to cube both sides, giving me 1 meter cubed is equal to 10 to the 9 millimeters cubed. So you can see I can cube this, I can cube that, I can cube this, and I can cube that. Next line, 4 kiloliters per millimeter cubed, 10 to the 3 liters, 1 kiloliter. Three times 3 is 9. And again, 3 times 3 is 9. Cancel out our units. Leaving me with milliliters per kilometer cubed. 4 times 10 to the 3 times 10 to the 3 times 10 to the 9 times 10 to the 9 milliliters per kilometer cubed. Combine all of these. 3 plus 3 is 6, plus 9 is 15, plus 9 is 24. In proper scientific notation, therefore that is your final answer. So once again, when dealing with rate conversions, make sure you put the right value in the numerator or the denominator so that they cancel. Remember that conversion factors can be inverted and the value does not change. For exponential conversions, make sure you apply whatever that power is to both the numerator and the denominator of the conversion factor. Please don't apply that cubic unit to the original value, only to the conversion factor. So in today's lecture, we expanded our knowledge of conversions, doing both exponential and rate conversions. In our next lecture, we'll talk about how to convert non-SI units. For instance, converting from centimeters to inches or pounds to grams. That's all for today. Until next time.